Hello everyone. Good morning for Mr. Anto and all my friends. Today I want to presentation what I've been read about the two journals that Mr. Anto have given to us. So let we start. As we know, these two research papers have two different perspectives, namely finance and computer vision. In the first paper, CNN is used to investigate advanced ANN or artificial neural networks for predicting the stock market. Meanwhile, the second paper discusses how sequencer in LSTM can be used for high performance in classifying images. This discussion covers the perspective interesting from my perspective, and then behind each paper, their objective and how they were implemented are combined by in-depth analysis for understanding. So, on CNN overview, the first paper proposes a CNN-based model that can predict future stock market movement by learning from historical financial data. The paper also states that CNN employed two CNN architectures, namely 2-dimension and 3-dimension, to effectively process temporal and cross-market futures. The temporal means futures here refers to detecting daily stock prices, transaction volume on charts or graphic, and local trend patterns. Meanwhile, the second paper explains that sequencer is rival to CNN and images classification by processing an LSTM-based architecture. Sequencer can learn spatial dependencies and image data through deep and highly organized LSTM layers without relying on convolutional filters. Spatial dependencies here are used to detect patterns in graph and identify anomalies in market graph. Meanwhile, the convolutional features are tools to enable CNN to automatically extract important and relevant features from input data, example images, in efficient manner. So the first paper, the purpose of CNN prediction was in financial forecasting. Number one is complexity of financial data. In the field of finance, data is important and random. So traditional models used such as ARIMA and CFM are often inadequate for capturing dynamic patterns. And the second, need for automatic futures extraction. As we know, when we input the data, we still using the manually to create features, and then we start to note every historical transaction, and then we put into one file that is raw file. So CNN can extract that raw file to representation directly from raw input. The raw input means is like the raw file that have been created by us. So third one is intermarket dependencies. By leveraging 3D CNN prediction can capture relationship between market indicators and different regions. So the second paper tells us the purpose of sequencer is number one is limitation of CNN. As we know, CNN is only can detect a few images, not so detailed. and then we put the LSTM to CNN, and or we combining CNN and LSTM for more accurate prediction. So despite their strength, CNN have a fixed resistive field and often ignore long-range dependencies. That's what I say, and CNN have a fix right here. Often ignore long-range dependencies. So number 2 is connection sequence and spatial modeling. Images can be viewed as sequence. Example, row by row scans naturally, and LSTM are naturally suited to learning from the sequence. Number 3, model simplicity and interpretability. STM offer a structured and interpretable architecture, which may enable insight into how features evolve in the spatial domain. From my perspective, there's some interesting point of view about the journals is that CNN prediction and sequencer address completely unrelated problems. Financial prediction in images classification. However, both challenge conventional assumption in their respective fields by questioning which type of deep learning architecture is appropriate for a particular data format. For CNN prediction, it requires detailed financial data in structured visual format, enabling CNN to identify patterns across the time, dimension, and variables when analyzing market charts. Meanwhile, the sequencer treats image as sequence, allowing traditional LSTM models to capture spatial dependencies. So, here's my conclusion. The conclusion is comparative study reveals how deep learning architecture can be transcend the limitation of traditional structures. CNN prediction demonstrate how convolutional method that can model non-images data such as stock markets. On the other hand, sequencer can help CNN to be more accurate in their prediction by using LSTM. Both papers reflect a collaborative effort in machine learning. Innovation is not only achieved by reinventing models within a single domain, example, only images alone, but also by leveraging exciting models. Their insight open doors to cross-model inspiration, reminding us that creativity in architectural design is just important as performance. So, this is my presentation. Thank you for your attention. Bye-bye.